Welcome to your walkthrough video of the questions. These should be relatively straightforward, but this is just to help you out and give you maybe a couple little strategies that you can use, particularly for this method where we're using inspection. So, first questions we've got here are from question number 3, and basically we want to find out what this missing value is. So what our question mark is. So what you do, play around with it. So 4 plus what can give me 7? My answer for that, if I do 4 plus 2, gives me 6. You can have your calculator next to you, which I find quite helpful as well. So if I do 4 plus 3, I do actually end up with an answer of 7. So my missing number for this one is actually 3. And I can always double check that by substituting it back in. So 4 plus 3 does indeed give me 7. Similar method on here as well. So 13 equals some number plus 3. So I have 3 and I'm adding something to get to 13. I reckon that one is actually 10. So if I try, and let's double check, 13 equals 10 plus 3. Yep, that's correct. And again, we're using that method of substituting it in to make sure that we've got the right answer. So we've now got 42 equals some number multiplied by 7. So if I try 7 times 7 gives me 49. No, that's too high, but it's quite close. It's actually 7 off, so I'm actually going to try 6. Let's double check. 42 equals 6 times 7. 6 times 7 does indeed equal 42, so that statement is true. Next one, I've got 15 plus 16 equals some number plus 1. When you have ones like these, it's really good to actually answer one side and then it'll help you with the other. So 15 plus 16, excuse me, actually gives me 31. So I want to have my left-hand side of 31 equaling my right-hand side. So I've got something plus 1 gives me 31. So I'm going to try 31, apologies. I'm going to try my 31 equaling 30 plus 1. That seems nice and easy. And it does actually equal 31. So my answer for my missing one is actually 30. Next one. So with these ones, we're looking for the unknown pronumeral. Think about that kind of balance method. It may help you to have a go at playing around with some different things to actually figure out, okay, if I've done something to one side, I can do it to the other. So if I've got, wow, I've written that incorrectly. My apologies, gents. If I've got 4 plus x equals 12, what number plus 12 is actually going to give me, what number plus 4? Sorry, what's 4 plus a number that's going to give me 12? One other way that you could do this is you could actually start using this balance method. And if I'm using that balance method, if I have 4 here, I want to take that 4 away. So I just have the x left by itself. So if I take 4 away from here, I have to take 4 away from here. So 12 minus 4 is actually 8. And I can double check by substituting it in. 4 plus 8 does indeed give me 12. So my value for this one is, my x value is 8. And I've double checked that. Next one, I've got 4b plus 2 is 35. So I'm going to use a little bit of that balance method again, but it does help you when you're doing these types of things. So if I've got 2 over here, but I want to get the b by itself, I take away 2, and I take away 2 on one side. As long as what you do to one side, you do the other. So 35 minus 2, I end up with 33. Okay, so now I've got 4b equals 33. Bit of a weird number, but don't worry, we'll get there. Okay, so if I've now got 4b equaling 33, this means that I've multiplied by 4. So let's try to do the opposite, which is dividing by 4. And we've used a little bit of this before, so why not try again? As long as what we do to one side, we do to the other. So if I put into my calculator 33 divided by 4, I end up with a bit of a weird number, but that is absolutely okay. Sometimes you might end up with a weird number. So I end up with my value for B, because I can cross those out, ending up being 8.25. Bit of a weird one, but have a play around with it and you will get there eventually. Okay, next one we have, again, similar method. I've got 8 multiplied by some number of y equaling 64. So let's try 8 times 7 is 56. That's quite close. Let's try 8 times 8. That gives me 64. That means my left-hand side equals my right-hand side. So my value for this one will be 8. Next one, again, have a think about maybe that balance method too. So if I'm multiplying by 3 here, to undo that, I divide by 3 on both sides. So 3 divided by 3 cancels each other out. Then 18 divided by 3 actually equals 6. And I can double check that. So let's just write in our answer. Let's say it's 6, and I can always check. So 6 times 3 does indeed equal 18. Beautiful. Last two for this question. So I've got L plus 2 gives me 14. So if you want to do that balance method, you can take away 2 from this side to get only your L. And if I'm taking away 2 from this side, I take away from this side. So L will give me 12. And I can always check using that method of substituting in. Next one, so a number plus 7 equals 19. So let's have a go at some numbers. Let's try 11. 11 plus 7 is 18. Really close. So let's try 12. 12 plus 7 is indeed 19. So my answer is 12. Next one, again, we're solving by inspection, so think about how you can kind of double things and you're just playing around with it until you can kind of get where you need to be. So I've got a number, double a number, take away 1, gives me 5. So I need this to equal 5. If I'm playing around with this, let's do maybe 2 times 2 is 10. So 10 minus 1, nope, that doesn't equal 5. So let's have a go again. So maybe 2 times 1, which would give me 2. So 2 minus 1 does not equal 5. Might have to play around with a couple of these ones. I'm going to use my balance method in particular for this one. So if I have gotten minus 1 here, that means the reverse is going to be plus. Those two cancel out. So I've got 2p equals 6. If I want to undo my multiply by 2, I divide by 2. And what I do to one side, I do the other. So I actually end up with 3. So if I do 3, so 2 times 3 is 6 minus 1 gives me 5. You can absolutely do it that way, or just keep going through and playing around with it until you get that answer. But that is one other way that you can do it as well. Next one, I've got 4q minus 4. Let's use our other method. So we're not going to do the method of kind of balancing out. So we're just going to plug things in and see how we go. So if we do 4 times 2, it gives me 8. So 8 minus 4 gives me 4. Okay, that's a little bit too low. So let's try another number. So let's try 4 times 4. So 4 times 4 is 16. 16 minus 4 gives me 12. Okay, we're getting closer. So let's try maybe 3. So 4 times 3 gives me 12. 12 minus 4 does give me, so 12 minus 4 gives me 8. Beautiful. My left-hand side equals my right-hand side. So my answer for Q, when I've played around with it, is 3. Next one. 2b minus 1 equals 1. Again, one of these kind of weird ones, but that's okay. We'll get there. Let's have a go. Because it's quite low as a number to end with, start low with a number you're substituting in. So anything kind of 3 and below. So if I do 2 multiplied by 3, minus 1, that gives me 5. Too high. Let's do 2 multiplied by 2 gives me 4 minus 1 is 3. Nope. Let's do 2 times 1. So 2 times 1 is 2 minus 1 does indeed give me 1. So I have my answer, and my B value here is going to be 1. And again, I can always double check that by substituting it in and making sure that that statement is true. Next one, again, playing around with this. So 5 multiplied by a number plus 5 gives me 20. Let's have a go. Because our number here, again, it's not too high, so let's try something low. So let's try 5 multiplied by 2 plus 5 gives me 15. I'm close. So 5 multiplied by 3 is 15 plus another 5, it gives me 20. So we've just found our answer for this one. So my value of G is actually 3. And again, substituting it back in to double check. So we've got 15 plus 5 does indeed give me 20. Okay, keep going with these ones. We're up to number 7. Solve the following by inspections. And we've been told that our solutions are between 1 to 10. Okay, so don't go too big, only 1 to 10. Okay, let's have a look. Let's just have a play around with this to start off with. So, if I'm doing, let's try 7 plus 3 to start off with, equals 2 multiplied by 3. So I've got 10 equaling 6. Okay, too low. So let's try something a bit higher. So again, you're going to do this process a couple of times until you get to where you need to be. So if I try 7 plus 6 equals 2 times 6. So 7 plus 6 is 13. And 2 times 6 is 12. We're getting close, okay? So let's maybe try another one for here. Let's try this time maybe 7. So 7 plus 7 gives me 14. 2 times 7 also gives me 14. So I have my answer there, my value for x to make this equation, this statement, this equation true is 7. Beautiful. Let's keep going. So I've got 10 minus x equals x plus 2. Again, let's just start with plugging in some numbers. So let's do 10 minus 3. Equals 3 plus 2. So 10 minus 3 is 7. 3 plus 2 is 5. Okay, that one doesn't work. Let's try something else. So let's try instead maybe 2. So 10 minus 2 is 8. 2 plus 2 is 4. Nope, they don't add up either. So let's try something a bit bigger. We've tried 2. We've tried 3. Let's maybe try 4. So I've got 10 minus 4 gives me 6. And 4 plus 2 gives me 6. Boom, we've found our answer. So our x value here is indeed 4. What did I write? 6. My apologies. So our x value is 4. Moving on. We've got a couple more questions and we are done. So next one. Again, you're playing around with it until you get there and where you're after. So 15 minus 2x equals x. That's a bit of a weird number, so let's maybe start quite low because we know we're going to end up with x by itself. So let's try 15 minus 2 times 2 gives me 2. So 15 minus 4 does not give me 2. Okay, so let's maybe try something a bit bigger. So let's have a go again. I'm going to try now maybe a number of 3. So 15 minus 2 times 3 is 6. Gives me apparently 3. So 15 minus 6 gives me 9. Okay, 9 does not equal 3. So let's keep trying. Let's try another number. We might have to make it a bit bigger. Let's jump to, say, 5. So I've said 15 minus, apologies. So I've said 15 minus 10 equals 5. Yep, I've found my answer. And my value for x as my answer will be 5. Next question. So these are the worded ones. Just a couple of reminders on these. So less than means that I'm minusing. More than means that I am adding. If I am dividing something or divided by, that means that I'm dividing. And that means that number has been divided. If the word is at the end of the sentence or towards the end of the sentence, that means equals, and giving a result of also means equals. So we've got the two that we're doing here. 3 less than a number. Let's say for all of these, my number is going to be x. So 3 less than a number. So I've got my number of minus 3 because I'm less than is 9. And it says that I want to actually find the value for each of these. So I need to find out what my number is. So I'm going to have my number here. I'm going to just represent it as n, my apologies. And let's actually have a go at finding it. So I'm going to try 6 minus 3. Nope, that doesn't equal 9. Let's try maybe 12. So 12 minus 3. Yep, that equals 9. So my value for my number, which I've represented here as n, is actually 12. And then we keep going with our other questions. So I've done B, now I'm on to D. 7 more than a number. So let's make our number n. And it's more than 7. 7 more than a number is equals 40. Okay. So now let's have a go at actually playing around with it. This one's going to be quite big. So what's a number plus 7 to give me 40? If I play around with it, so let's do 33 plus 7 gives me 40. Beautiful. So my number in this case is actually 33. And again, I can always double check that by substituting it back in. And my right hand side equals my left hand side. Beautiful. Done. Next one, F. 10 is divided by a number. So I start off with 10. So 10 is divided by a number, giving a result of 5. So giving a result of 5. Let's put that 5 in there. So what's 10 divided by something to give me 5? So I should actually play around with that. So 10 divided by 2 gives me 5. Beautiful. So my number is indeed, again, for this one, my number is actually 2. And again, I can always double check that. So 10 divided by 2 equals 5. So 5 equals 5. Beautiful. Okay, last couple of questions, and these are towards the end anyway, particularly for Group A. 9 is an extension. For Group B, have a go at it though. So Justine is paid $10 an hour for X amount of hours. During a particular week, she earns $180. First thing we're going to do is we're going to write an equation to actually represent this information. So let's do that first and foremost. So I've got $10 per hour. On this weekend, she earned 180. So I have my equation there. Let's make it a little bit neater. So 10 times x equals 180. Now we need to actually solve it. We need to find the value of our x for letter B for question 9. So I need to find out what my value for x is here. So I'm going to write my equation again. So I've got 10x equals 180. So what times 10 gives me 180? I'm going to try, just as a wild guess, I'm going to try 10 multiplied by 18. That does indeed give me 180. And 180 absolutely equals 180. So my value for x in this case is 18. So if you were asked the question for this, how many hours did she work? She worked 18 hours. But it's just asked us to find the value of that x. Next one. Taylor buys X amount of kilos. So we don't know how many at this much per kilo. So this much per kilo. So we're going to be multiplying again as we did just before. So I've got my number 450 and I'm multiplying it by X because I'm writing my equation, which is what the question's asking me to do. And she spent a total of $13.50. Okay, that's looking pretty good. Let's tighten it up, neaten it up. It always looks nicer when there's less symbols to actually look at. Okay, and we want to find out our value for X. So I had 4.50x equals 1350. So play around with this one. But essentially what you will end up with is you've got your 1350 that you want to divide by your 450. And I actually end up with, it kind of looks roughly, if I was to say that this is, say, 5x instead, I can kind of estimate. This is close to 15. So if I try 3 times this, yep, chucked into the calculator, it actually gives me this one as well. So my value for x in this case is 3. And again, I can always double check that by multiplying and substituting it in. And it does indeed give me my answer. Last one, Yanni. Good old Yanni. His current age is Y years old. So let's put that Y down so far. In 12 years' time, so that means I'm adding time. So let's add that 12. So in 12 years' time, he will be 3 times as old. So that means he's 3 times as old as he is now. That's looking really good. Now, we want to have a go at actually coming up with what the answer would be. So, play around with this, but you will kind of get to where you need to be. So, I've got y plus 12 equals 3y. If I am doing that kind of balance method, which you might have to do with these types of questions, if I want to get rid of the y on this side, I have to minus it, and I can minus it over here. So I end up with 12 equals 3y minus 2y is, 3y minus y is 2y. And then I can divide both sides. So I've got 6 equals y. So how old is he now? He is actually 6. Fun times for Yanni. And you're done.